Hello. Hello, Giselle and everyone.
Good morning po.
Good morning, Alvin. Good morning, good evening, everyone. Welcome to the PAASE for Philippine Innovation Fireside Chat Series. I'm Giselle Concepcion of PAASE and currently serving as an executive member of the National Innovation Council. And PAASE is one of the staunch supporters of Philippine innovation. And today, we have a very special guest who will share with us her initiatives in UP Diliman on her work on antimicrobial resistance and other microbial and immunology projects. But what's unique about her is that she is pursuing this work with innovative methods. And I'm particularly elated about our speaker today because she worked as my RA, and she was our master's student some decades ago before she went to the United States for her PhD studies. And she had promised me to come home for good when she left for her Fulbright scholarship, and she did. And now she's one of the valuable faculty members of the UP Diliman's Institute of Biology. I will hand over the floor to my co-host, Dr. Alvin Culaba of De La Salle University, a distinguished professor of mechanical engineering, vice president of the National Academy of Science and Technology, and also Dr. Culaba served as past PAASE president, just like I did. So I'd like to welcome our special guests and participants today, and we will recognize them as we go along our event today. Thank you very much. Dr. Alvin?
Yes, good morning, Giselle, Concepcion, of course, Academician Concepcion. Good morning, everyone. Good evening in other parts of the world. We are again here in our Friday Fireside Chat series, PAASE for Philippine Innovation. Today, indeed, we have a very special guest. That's right. Giselle mentioned, that she is a balik scientist. She obtained her PhD from the Department of Immunology, Microbiology, and Parasitology of the Louisiana State University Health Science Center in New Orleans in the US. After her 9-year Fulbright stint in the US, she went home through the Balik Scientist Program under the UP Office of the Vice President Academic Affairs of UP System, that time headed by Dr. Gisela Concepcion. In 2014, she founded the Immunopharmacology Research Laboratory at the Institute of Biology at UP. And 3 years later, she served as visiting associate professor of the Molecular Biosciences, Washington State University, with support from the USAID STRIDE. And in 2019, she was appointed as a University Innovation Fellow of the UP Systems Technology Transfer and Business Development Office and served as a Project Development Associate for Innovation at the College of Science in UP Diliman. Our speaker today advocates for global efforts to mitigate the emergence of antimicrobial resistance. Served as guest co-editor for Frontiers in Microbiology, special issue titled Antimicrobial Resistance Along the Food Chain. Are we what we eat? Indeed, our speaker for today is an innovator. She uses innovative educational tools to help nurture the next generation of scientists, educators, and innovators in the Philippines. Ladies and gentlemen, it is all welcome, Dr. Joyce A. Ibana. Joyce, the floor is yours.
Good morning, everyone. And thank you very much for this very kind and generous introduction. So what I will share with you is what we have done at the Institute of Biology in Diliman. And as mentioned, I actually came home in 2013. So this is actually my 10th year as Balik PhD program grantee of UP system. And initially, when I received this invitation, it was with a little bit of worry, because I know that PAASE members are very well renowned in the world, and there's so many good presentations that has been showcased here in this fireside chat. And I thought, well, I'm not that good as many of PAASE members are. But then, to honor those who've trained me and also those who believed in me, I will also say that I'm not that bad, and I will share with you what we have accomplished. And I want to showcase what the investment on education has done after 10 years of our research laboratory. So my talk is about, I will focus on antimicrobial resistance, but I will share with you a story about what the outputs of the investment of our government to a research laboratory, which I founded in 2014. So IRL is in Institute of Biology, UP Diliman. And so we've been supported by USAID Stride and my Balik PhD grant in 2014 to 15. And we've received support from the OSTP Shared in 2018, and from the Office of Vice Chancellor for Research and Development, as well as NSRI. So over the 10 years, we've received approximately 18 million for 10 years funding support. And what we've accomplished for that amount is we've established 2 laboratories. One is at Natural Science Research Institute, where we stayed and started our probiotic research. And then we built this Institute of Biology, IRL laboratory, which supported many research projects of our students. So this is our infrastructure development. And for that, we've graduated many students, 8 masters and 3 PhDs, and 2 of the master students have actually come home and now serving our country. So we have 5 PhD students that are who are now working as PhD graduates here in the Philippines. And our students have been recognized nationally and internationally for their research, as well as for their academic excellence. So currently, we have our outputs in human capacity building, 5 PhDs, and we have now 7 MDs. So we've graduated 24 IRL graduates from that investment of the government. And we have 2 entrepreneurs. Actually, one is in the creative industry, and the other is actually very active in the startup community and has been awarded by the World Health Organization for innovation for his work on in immunology for vaccine compliance. And so in terms of research output, we produce scientific articles, book chapters, and if you would notice, in terms of our outputs, the diversity of our research output increased after my first half of work here in the Philippines. And this is also coinciding with my appointment as a University Innovation Fellow of UP System, as well as the training of a USAID Stride and featured on innovation, particularly the knowledge and technology transfer. So after that, the first half of my work here in the Philippines, we produced copyright trademark. So we trademarked 2 brands, Nice Forgot, which is for functional development, and the other is for Real Data Arts, which is a communication platform for scientists. And we've produced, prototype, and launched it in the last 3 years, one for Real Data Arts and one for Nice Forgot. And we've disclosed invention, and we have one IP filing last year. So in terms of innovation, so I think that when I actually was thinking of what my talk could contribute to this innovation series, is that previously we've seen innovation from a more focused perspective, where they actually really entered into the market and done a lot of enterprise. But here I will show you what a academic research laboratory may be able to contribute to our innovation ecosystem. So the kind of model that we have is that we will be able to generate many early stage technologies. And here I was just showing you some in terms of different types of IP asset, like processes, products, or materials. So we've generated a microbial library and have actually characterized this genetically, and we have this potential for food processing and industry. So we have different applications for health, for pharmaceutical, and for agricultural and food industry. So I guess that's the different kind of perspective. So a research laboratory may not have something that's already in the market being used by our society, but we have the potential to actually contribute to our innovation ecosystem through the thesis work of our students. So from the 24 research completed, we have this potential technologies that we can partner with industry to develop and actually come to fruition to be in the market. And in terms of IRL collaboration, we collaborate with different institutes within the College of Science. We have collaboration with Institute of Mathematics, Chemistry, Marine Science Institute, and Natural Science Institute, as well as the home economics. So I previously collaborated with the late Alonso Gabriel for one of our projects. And within these, the Institute of Biology, this is actually housing about 30 PhD faculty, and we actually converse and collaborate. So in terms of industry collaboration, I engage with a lot of our industry here in the Philippines, but I'm just showing you some samples of those wherein I partner to produce research work that are actually already has some early stage development output. So I've collaborated also with our SUCs for our poultry farm, poultry systems, and with Malagos for our food development projects, and also with collaborators like Dr. Mario Hies and Dr. Claro Mingala of Philippine Carabao Center. We've actually provided a proof of concept through a research project where we showed how we can make an anti-Carabao antibody. So this is useful for immunoassay. An anti-Carabao antibody is there's no anti-Carabao antibody in the market. So we tried to demonstrate that we can actually generate that. And for our Real Data Arts venture, we collaborate with productions in industries like printing industry, and Habe is another production industry. So now we go to the meat of my talk, and I want to show you an example of some of those innovations that we've done in our laboratory. So the first is our Real Data Arts is an innovation in science communication, and poultry science, a poultry system is in discovery phase. And Nice Forgot this. Here we have a more advanced technology level readiness, and it's in innovation in food. So I just want to give you a flavor of different types of work that we do. And I think the other value of this is you kind of get a glimpse of what a research laboratory that actually started from really just asking basic questions. Because I would consider myself as primarily a basic science researcher by training. So, and actually, this is where I actually, upon reflection, when I was doing my scientific training, I was actually more tapping into my artistic inclination. And I think you'll find it interesting that I actually studied chlamydia, trachomatis in the US, but I'm more focused on cell signaling pathways. I was curious about the mechanism that are involved in the pathogenesis without realizing what it is in the real world, what it really means, what is the problem about this organism in the real world. I was hyper focused on understanding molecular mechanisms, how this protein and how this bacterium interact with a human host cell. And I was looking at this because it's fascinating, it's beautiful, and it's really a very interesting basic science question. But during the course of my studies, I actually discovered that there is a small molecule called L1MT, which is in an early stage of phase 1 clinical trial for as an anti-cancer agent. But I will also notice that it acts on the same cell signaling pathway that is involved in the induction of this persistent growth form, which is resistant to antibiotics. And just to put it in context, this is the persistent form, and this is the natural course of the cycle where it will produce many infectious particles that will be released to infect neighboring cell. And so with this repurposing strategy, what happened was that I was able to trick the chlamydia not to enter into this doxycycline resistant form, which is persistent and can cause chronic disease. And instead, it enters into a novel growth form wherein I was able to induce the expression of late genes. And this actually resulted, you can imagine, to my surprise, I was able to induce empty inclusion bodies, so without these infectious particles. So therefore, this results in a growth form that is not producing infectious particles and also makes it susceptible to antibiotics. So that's that. I mean, the innovation there and also the creativity is actually to be able to connect something unrelated to what you are studying and actually knowing the basic mechanism of a signaling pathway can actually be helpful in understanding and discovering new and useful uh, um, utility. And this actually ended up as a cover of Infection and Immunity and American Society Journal. And what actually I share is something that I hope when some students would actually see this work. It started with a really very difficult question from my mother. So when I achieved this, she asked me, "So what did you get out of this?" And I would like to share this because, so my mother is now 94 years old. She's practically survived World War II and the pandemic. And she is a great teacher. And so I realized that asking a question is actually at the start of actually a cascade of thinking and creative process. And from henceforth, I entered into this phase where actually I was thinking about molecules and entered into this phase where I started to think, what does this mean in terms of humanity? How does my work actually relates to what is important to human lives? And during the pandemic, I was actually inspired by the presentation and sharing of Father Nebres about his program on alleviating hunger. And what I realized then, it is not because a problem is not relatable to us and we think it's not a problem of our concern. Not because we are not hungry, we should not actually care about solving this problem. And what I realized is that I actually wonder, why did I study chlamydia? I even didn't know what it is, and I don't know whether it's a problem. And but actually, I knew from just in readings and my work is that there is a transformative experience here in the Philippines. There was a high school student who asked me during a science fair convention whether concerned about chlamydia. And I was thinking, and I started a conversation, and I realized it's a real problem. And now I realize that with my education and training, it becomes a responsibility to actually communicate the perils of chlamydia, because this is a silent disease. Not many people actually probably realize that chlamydia can actually cause infant pneumonia and neonatal conjunctivitis when a mother is actually gives delivery to a child when she's infected with chlamydia. And also because of those antibiotic resistant treatment, where you have the persistent form, it can actually reactivate and cause scarring in the fallopian tube, and can cause is a major cause of infertility, tubal factor infertility. And importantly, I even published a paper showing the potential mechanism on how co-infection with chlamydia can actually increase the risk of HIV infection. And this is a real problem. This is still a problem in many parts of the world. So so this is the premise of how we've actually entered into this. So in innovation, it's actually important to be able to empathize and find creative ways of actually helping our community. And this gave birth to the concept of real data arts. So this is a platform for scientists to actually think of how we can enter into the mainstream market and actually communicate the importance of our science in the real world. And I would like to acknowledge our students who actually contributed to the work, and the advocates who actually helped us make this to launch this product and innovation into our community. So early this year, in August this year, we were able to join the Bayanihan sa UP Diliman as an exhibitor. And we've prototyped to test the idea of what if you actually showed, where my motivation was the beauty of confocal microscopy and the colors of chlamydia when you do cell biology study. So we set up this booth, and you can imagine we attempted to present a poster. So usually as we scientists, we present our poster in scientific community, and we talk to another scientist, we talk about our science, and we come up with a paper, and we talk to another scientist, we collaborate, and we come up with another paper. So this one, I've exposed myself in presenting a poster in a setup where I actually interact with different segments of our society. So this is the setup. So we have, along with people with MSMEs who are selling calamansi juice, bags, clothes. I was there along with my students presenting science. And so so there's different conversation about, I have the opportunity to explain confocal microscopy, about cell biology, about chlamydia. And there's a varied audience, like other scientists, other students, other merchants, and so on and so forth. And the outcome of that is that I was able to communicate the perils of chlamydia in a way that when they come home, they will actually have an item that will trigger a question in their mind and will help the cascade of inquiry. And especially in this age where information is available at our fingertips. So you can, if something matters to you and your curiosity is triggered, you have the capability to actually think about this and learn more about this. And this is a self-sustaining enterprise, because now you don't have to have a venue where you do a webinar and you talk about the science. You can actually have this as a self-sustaining communication platform for what you want to advocate and what you want people to learn. And interestingly, there's a lot of interest of this with other scientists. I spoke with another geologist, and she showed me some beautiful photos of rocks, and also there's an engineer who we talk about plasma and how it's actually interesting and beautiful. And so we actually just validated this, and among the 37 respondents, so we have this feedback form, and there's almost the majority are interested and they have the intent to purchase. So that's a real data arts. It's probably a very non-conventional and probably very a different way of looking at things. But we want to try to do this, and actually there's a lot of interest among other scientists to actually use this platform, and we're thinking of this as a social enterprise where we can actually help a self-sustaining enterprise to actually promote science in our community. So that's real data arts, and now we shift gears to poultry farming. So we focus on science in our discovery process. So this work is from the two PhDs who graduated from our laboratory, and they are now collaborating. So Dr. Michael McDowell's students actually also participated in this work. So now I'm officially an academic Lola. And we have collaborators from State University, and we have resources from other laboratory institutes. So this is a story about how curiosity can evolve into a purposeful research endeavor. And this is actually what happened. So I was in the province in Bicol, and I've heard this conversation about antibiotics can make chickens fat. And it's the first time that I heard about this, and I asked, is that actually real, and how would it happen? So as a scientist, it's actually triggered my curiosity and interest about this topic. Because on the other hand, I was thinking, if that is practice, then wouldn't it be a problem in antibiotic resistance problem? So in antibiotic resistance, and I guess in the context of our farmers, I probably would think, so this is the product of imagination. Yes, I would
brown dye.
So first, we actually look into this reality whether use of antibiotics could actually lead to emergence of antimicrobial resistance genes, and this is published in Tropical Biomedicine. So we did a controlled experiment of poultry farming practice where we mimic what antibiotics are used for growth promotion. And we've demonstrated that actually, so we raise the chickens without antibiotics, and they don't have the antibiotic resistance genes to begin with. But after antibiotic treatment, these antibiotic genes would emerge at 7 days for antibiotic treated chickens, and at 21 days in non-antibiotic treated chicken that is raised in the same farm. So we've had that evidence, and we also did a meta-analysis to check this, the chicken actually get heavier with antibiotic treatment based on studies by other groups. And we saw that there are some evidence that it is heavier, and it's also supported by lower feed conversion rates. So, and this is important because we have to balance, as scientists, we need to realize that we have to balance the productivity of our food production, as well as taking care of antimicrobial resistance, which is not visible easily for others. This is not something that would impact us within our immediate time and space, but like global, but like the climate change is something that we don't perceive in our immediate reality, but is something that we have to actually think about. And it is a responsibility of scientists, and not to overburden the businessman and also the farmers who's actually doing so much already for the food production and also for providing job opportunities, etc. It's something that we have to really think how we can contribute to the system in a way that we actually balance things. And when we actually look at the meta-analysis of antibiotic prevalence rates in countries where there is a regulation of the use of antibiotic versus those which has no regulation, we find that unregulated antibiotic use is correlated with increased prevalence of antibiotic resistance in our initial meta-analysis. So our idea is to actually study this further, and we don't stop by policing people about this idea that there might be emergence of antibiotic resistance. I think the focus is really to find alternatives and actually mitigate this problem through policies and alternatives to improve the system. So that's the innovation there. We improve the system. So what we did is to understand the mechanism involved in antibiotic growth promotion in order to find sustainable alternatives for the broiler industry. So what my student actually started with the question is how exactly antibiotic growth promotion works. So we wanted to investigate this mechanistically. And we actually, so interestingly, the first question is, does it actually induce obesity? So we've done this study on treating the chickens with antibiotics using a farm prescribed protocol. One of the farmers that we talked to. So this is one of the protocols. And what we actually demonstrated is that indeed there is an increase in intraperitoneal fat, and there is an increase in intraperitoneal fat body weight percentage. And we've also looked at the glucose and lipid serum levels, looking at this from chickens treated with antibiotics, and of course with compare this with the control. So with that in mind, the next question that we ask is, with the development of this obesity, we wanted to test whether inflammatory mechanisms are observed in antibiotic-treated chickens. And so the adipocytes that we've collected, we did a gene expression analysis. And what we found is that there is an increased level of TNF alpha in this adipocytes. And then we cultured this and grow this and differentiated this using oleic acid and then we challenge it with lipopolysaccharide. And we find that it actually produces more IL-6, which is another inflammatory marker. So what we actually found is that this actually induces an inflammatory milieu in the tissues of chickens. And the other thing that we actually investigated is what has happened to the gut microbiota. So we have this protocol. So instead of looking at the feces of chickens from the floor, we actually put a tape in the butt of the chicken to actually collect the fecal material and actually analyze the microbiota of these chickens. And what we realized is that in this antibiotic-treated chickens, there is this yellow. Because when we look at diversity and microbial composition, there is this bacteria that predominates in compared to the control in the antibiotic treated chickens. And this bacteria is associated with a synthesis of linoleic acid, and this has been implicated in the development of chronic inflammatory state and in obesity. So with these findings, we have these pieces of the puzzle of this mechanism where with the antibiotic growth promotion, there's increase in this type of bacteria and perhaps increased absorbed linoleic acid. And when we look at the literature, under a pro-inflammatory milieu, this can actually lead to the increase in adiposity. So this we have some pieces of the puzzle that we still need to investigate, but understanding mechanism is key to actually designing interventions. So when we so this I think is a good pieces of data that will help us understand and contribute to possible intervention and providing alternatives for the antibiotic resistance problem in poultry farming. And we need to have continuous conversations with the government, academia, and the industry that how we actually can provide better systems and improve systems and innovative system for our poultry industry. And we hope that we are creating a preferred scenario for the future of our poultry system, because they are a very important industry, and we want to help in addressing problems that we don't want to burden our farmers and our entrepreneurs. And it's actually the responsibility of us in the academe to solve this problem. And so that's that. And finally, I will share with you our functional food development, Nice for God, food innovation platform. And I would like to acknowledge the students who have actually contributed to this work. And primarily, this is a master's microbiology study of Janina Duarte and food science thesis of Miss Ingrid Pentespina. And this is along with my collaborators from Institute of Chemistry who's done metabolomics for this. We're not showing data, but we have them. But this is initially with Dr. the late Alonso Gabriel, who was the co-advisor of Miss Ingrid Pentespina. But this evolved from the many studies of students from IRL since 2015. So when I started the probiotic research, actually that was my Balik PhD grant. We're starting to look at the use of antibiotic because it's said to be it results to gut dysbiosis. We've actually investigated the potential to inhibit infectious bacteria and to be used for that to be used as alternative to antibiotics, and also as an adjunct treatment. So in the interest of time, I will not discuss many of this research, but I would actually share some. We look at the antibiotic resistance of some probiotic that we have, and we find that they are susceptible to amoxicillin and doxycycline, but they are resistant to ciprofloxacin. And we try to understand this observation, and we align the sequences of susceptible strains and with this strain, and we find that there is a mutation in gyrus B and PAASE genes which may contribute to this resistance. But this is actually located in the chromosome, so we don't know if there is a mobile genetic element that would transfer this, but then we actually, this is a neutral information. We don't have to be scared about this, because if you think about the risk and benefit ratio of using probiotics in terms of gut dysbiosis, actually we would also think if we actually administer probiotics along with antibiotics, are we just not killing the probiotics then? So we've actually did some dyadic and triadic interaction studies, and we've collaborated with actually mathematicians, with Dr. Guido David and his student Harold Thomas, and they actually mathematically model this interaction. But just to give you a glimpse, so this is a pathogen, and this is a probiotics under ciprofloxacin treatment, and this is this two under ampicillin treatment. So you get some ideas. So actually, those are the studies that started this idea of using probiotics to improve our food product and actually come up with functional food. And this is a story of courage and collaboration, because you can imagine, so I'm a trained immunologist and cell biologist. I was entering into food production, and or at least prototyping, and this would not have been possible without the collaboration from the industry with Mrs. Olive Pentespina and Ingrid Pentespina, who's actually been very, very inspiring and helpful in the accomplishment of this endeavor. So this is, to cut the story short, we prototyped this cheese product. It's a locally produced cheese product from Carabao's milk, using a unique process to create functional food with extended shelf life that is nutritious and confers gut health benefits. So along with my training in UIF, we've actually come up with this value proposition. This is something that would provide high energy and protein daily requirement, can act as a probiotic to treat gastrointestinal diseases, and can increase the compliance of completing antimicrobial regimen, especially for children and elderlies. And this is the performance result of this product. We've tested it in the intended market and showed its acceptability. And we've demonstrated its performance in terms of recoverable lactobacillus from the product, the probiotics, and we also demonstrated its health benefits. It has an anti-Shigella activity, and we've also tested whether it can survive the simulated gastrointestinal conditions by testing it in different bile condition and acid and acidity. And we've shown that this is the performance. And we've also looked at the nutritional analysis, and we've shown that this product is actually something that's a good alternative for what is currently in the market. So we have a low sugar and high nutritional content product. And so we prototyped this in 2020, and we actually have initiated the testing of this product after 3 years. And we've shown that it would, if you actually consider the FDA standard, is this would still have, it will pass this standard based on these parameters. So that's our nice for gut and we cheese, and we envision that we'll continue this product development in early stage and collaborate with industry to develop more functional food. This is a great opportunity in our country, which has high biodiversity. And so to end, I've shown you some glimpse of what our students can do in a research laboratory here in the Philippines. And this is perhaps something that we can contribute in our innovation ecosystem. And so at this junction, so after 10 years, we are ready to enter into a different phase. We want to collaborate with industries and other research laboratories here and abroad. And if you are interested, this is our QR code. This will direct you to our website. And of course, you can easily find my email in our website. And with that, I'd like to end with advocating for embracing diversity. As St. Therese would say, not everyone has to be roses. We can be daisies, lavenders, and what have you. But I want just to emphasize that this would not have been possible without the supportive environment of the Institute of Biology and of College of Sciences of UP Diliman. And I think for us in our scientific community here, to actually move things forward for our country and the future of our country and of the world, we actually advocate that together everyone achieves more. With that, I'd like to end, and thank you for your time and attention.
Thank you very much, Joyce. I appreciate your sharing today on many of your projects on many fronts with many applications that could benefit society. But I'd like to tell everyone that Joyce is an artist, and the vase of beautiful flowers is her creation. I'm so certain that that is painted by Joyce. And that is why I'm not surprised about her creativity in science, because it's the same kind of passion and creativity that drives science and art. So thank you so much, Joyce. Before I ask my questions, I'd like to yield the floor to my co-host, Dr. Alvin Kulaba, who will be leaving in 10 minutes. I think he's in Taiwan and he has another appointment or engagement. So Alvin, perhaps you can ask your question, and then I will ask mine, and then we will open the floor to our participants for their questions. And this is our usual format, Joyce, in this fireside chat. Alvin, are you there? Do you have a question? He said he would leave by 9:30. So because we can't get Alvin at this point, let me ask Joyce a few of my questions. Well, you ended with your work on the nice for gut cheese. And I was in UP Los Baños about 3 weeks ago, and I saw that in the stores along the quadrangle, there are now cheese products and milk products, various brands. And I was just wondering whether you could start with those small manufacturers that are selling their products in Los Baños. So it's a way to evaluate whether the quality of their milk and their cheese is good based on your standards. And perhaps you could also, share with the FDA. We have Annie Lobos here, our PAASE and the NASTA member, who is a consultant of the FDA regarding, these standards, this criteria that you would like to set as far as milk and the cheese industries are concerned. So that's my first question, Joyce.
Thank you, ma'am, for that very important suggestions that is worth considering, and also the suggestion about we're early stage development, and actually we need to study more about these FDA regulation and how we can actually make this products. We certainly need a lot of help, and we are actually we appreciate these insights. Thank you, ma'am.
Okay, thank you, Joyce. My second has to do with the poultry. So I'm glad you mentioned Father Ben, because both of us, we admire him for his advocacy on alleviating hunger and malnutrition, undernutrition in our country, especially for our children. Now, in regard to a protein source for our children, we know that poultry is one of the important sources. And then you talked about the antimicrobial resistance genes that are present, perhaps associated with antibiotic treatment. And then, of course, you say that we should not be too alarmed, and there should always be this attitude of risk to benefit. When we deal with food products, or even information that scientists understand, and then the businessmen and manufacturers and the public, the layman, don't fully understand. So one of the concerns actually about poultry, that is chicken products that we see in the market, is that yes, the ones that are imported from the United States are huge. They're bigger. And people have the impression that it's because they have been grown with antibiotics. And the immediate concern is actually that with the antibiotics in the poultry meat, then humans would also be ingesting the antibiotics. Okay, but then what you're also studying is antibiotic gene resistance genes in the chickens themselves. So can you please clarify this, Joyce? Is there a real concern about, ingesting antibiotics for chickens that are fed antibiotics?
Well, I have not done actually a study to really make a definite question about that risk. Certainly, I think that without that evidence, we should not be at this juncture so alarmed about it. That it's more important to actually solve our food security and provide food for our community. But what I actually want to emphasize is for scientists to actually be more participative in actually providing alternatives to antibiotics, discovering how we can actually make this a more efficient system with improved policies, because there are ways of actually doing this. And one of our study, which I did not actually present, we're actually doing microbial evolution in the laboratory, and we want to actually collaborate with mathematicians to actually see whether the withdrawal of antibiotics over a certain period of time. We've shown actually that through natural evolution of the microorganism, this actually the susceptible microorganism actually increase, and the resistant actually decrease over time. And I think that there's a holding period where you can actually create a better system, because we cannot actually just remove something that we actually know is helping the productivity and preventing diseases. But actually, another thing to consider, that's why we actually want at least to be aware of this, is when a poultry farm develops an antibiotic resistance, what happens when they actually need this antibiotic to treat their chickens that has a disease? So that's another consideration. That's why I think that it's important to think this through very carefully, and how we actually create a protocol where we actually balance these two benefits, and actually also solve this risk. I hope that answers your question.
Yes, Joyce, thank you so much. We know that the poultry industry now is faced by with another more imminent problem, which is viral diseases, is AI, right? But as far as bacterial infections are concerned, the antibiotics seem to be doing the work. And well, it's nice to see that you're able to correlate it with uh, higher growth rates and heavier weights for the chickens. And this is very important because we've heard the news that our local poultry growers are actually expanding their operations, led by San Miguel Corporation, which is building a very huge state-of-the-art poultry facility here in Luzon. So I think there will be a lot of use for the kind of research that you are doing, Joyce. You might as well connect with San Miguel and Robina and Monterey and all of these food manufacturers.
But ma'am, if I may just emphasize, there is actually a lot of alternatives to for growth promotion, and that has successful implementation. So I think it's also worth and expressing that, so that we don't get this impression that is, in a positive sense about things. Thank you.
Okay. Well, it looks like Alvin has had to leave, and we have a very, very nice group of participants today. And let me just acknowledge the presence of our guests today. We have past President Alsa Rafika of the PAASE and also of NAST. We have Sean Raimundo of PAASE and NAST. We have Gladys, our PAASE Vice President, but I think she might have left. There is Eddie Mendoza of NAS, or a corresponding member. We have Fred Alcantara, Dana Kalika, and then we have, well, from your group, we have Isabel Navarro. Oh, we have Marge Peña of PAASE, based in the United States. We have Myra Villarreal. We have others. I don't recognize all of them. And there's Ahmad, your co-faculty in IB. We have Dr. Rina Opulencia. We have academician and past President Toby Dairit. And we have Helen Mege and Janella Rodrino. So I would like to open the floor to the questions of our participants. Yes, you could. We could start with Dr. Alsa Rafika, followed by Dr. Shando.
Thank you. Can you hear me okay, Joyce?
Yes.
Yeah? Okay. Yeah, well, first of all, congratulations for a summarized accomplishments of your 10 years. I wish I had a list like that for myself, having been back also in the Philippines for 10 years. But nevertheless, I wanted to expound a little bit on some of the activities that you've done. And I know we are together at the UPTTBDO, some of our plans also moving forward. But it just struck me because I wasn't familiar with your chicken antimicrobial work, and clearly it opened up additional information on my side on how to connect you. So the key question is, I mean, chickens from the US are are bigger, mainly because they're grown longer. We had a US aid project with TUP at that point, where we connected with the United Broilers Association of Mr. Sisip, nephew of Wash Sisip at that time. And they produce about 8 million chicken heads for Manila alone for supply on a weekly basis. And clearly they said that most of our chicken requirements are on the 29 to 35 days, where the chicken grown in the US is 48 days. I think that's the numbers that I had. It's just grown longer because that's the requirements of here we're used to the tingy, so we're piece, but a smaller piece at that. So if you look at your current Chicken Joy, they're smaller now for the same price. So, but your antimicrobial resistance is not much different to a typical challenge from a compliance standpoint. First, from a regulatory standpoint, indeed, do we have a limit in terms of antibiotic content for meat? That's worth a question. I don't know, we do. And Japan is very particular about their milk production. I mean, the US was very particular about their milk production because of the use of BST, bovine somatotropin. And so a lot of the milk labels in the US, if you take at them, they say that they're produced with non-BST cows. So again, might be well for some of our more discerning. I know Singapore has very particular about their organic and non-antimicrobial containing meat in their menu. I think, I don't know if we can be selective, but I agree with you. Food security first, compliance later. But I think the best way to the entrepreneur's heart, especially for the chicken work that you're doing, is if you can do balance indeed an economic analysis. How much antibiotics are you using? How much is it costing you? And if we substitute some of those antibiotics, probiotic contents coming from our cultures, would that reduce your cost and still does not affect your food to weight conversion ratio? Meaning you still make the same money but less cost on the other side. So that's one question for that. So I think that's worth exploring together when we're in Iloilo next in 2 weeks. But I think having an economic team to do an economic analysis on some of these proposals would be very good because that's what's missing normally with our scientific activities. We don't monetize the value of our work. And that's one way to monetize it. And the same way for your Nice for Gut, which we've been trying to do work with Olive Puentespina of Malagos, and also with the doctors on the treatment of Shigella infection. Again, a cost-benefit analysis might be in order, but my key question right now is what's our status for the FDA? Are we a CPR registered already for Nice for Gut? And eventually, the hope is, of course, to have a special or an additional indication for may help in Shigella reduction infections. But I'll let you answer those two questions first. Thank you.
Thank you for those questions, Al. It's really been very helpful to think of those things in terms of the business side and also the regulatory side. And it's something that, as I mentioned, I'm a basic scientist. My journey has been like from looking at the things at the molecular level to actually I have to understand this in this context. I have no business background, nor do I have a FDA background, and it's certainly I welcome a lot of help from more experienced entrepreneurs and researchers and industry practitioners like you in the audience and others who may be interested to help. So in terms of your first question about the poultry industry and alternatives, I've started conversations actually, and somebody actually referred me to an economist who's in the poultry business, and we will start to actually assess whether the benefit actually outweighs the risk, and how we can actually mitigate the risk by providing alternatives. And for all we know, nobody has just really carefully calculated, but the cost may be more because you will have to by. But this is a hypothesis. We need an evidence for this, and we certainly have to communicate what is best, considering all the factors that we have to consider in terms of food security and safety. And as I mentioned, we really have to consider these things that problems that are not seen easily by farmers and our consumers, like antimicrobial resistance or climate change. We have to consider this because this may not have an immediate impact or something that can be seen easily within the present time and space, but can actually have a major impact on our society and our community over the long term. So as scientists, I think it's our responsibility. So in the next question about nice forgot, we are in that direction to actually look at and I have been speaking a lot and I was in mute. I'm sorry about that. I was mentioning about the importance of actually calculating the benefit and risk ratio in terms of poultry, and actually the regulation. We certainly regulatory bodies, we need to actually engage and actually look at how we can comply with these requirements moving forward. Thank you.
Thank you. Yeah, looks like we really have to do a calculation, so it's got to be quantitative data, right, Joyce? I'd like to call Dr. Sean Raimundo at this point.
Hi, Joyce. Congratulations on your good job, good work. Well, I was actually interested in antibiotic resistance way back in the 1980s when I just came back, and plasmid transfer of antibiotic resistance gene was the big issue then. And so my students came up with a study that showed that indeed the natural microflora of chicken dung are really resistant to the antibiotics that were being used at that time. At that time, there was no law against the use of antibiotics in feeds. And so we worked with the animal industry people and showed them about this. And they said, there's no law against it. So they still kept on using it. And we collaborated the use of tyrosine. Have you heard about that? It's an antibiotic. It's just for animals, for poultry, and not used for humans. But eventually it was proven that antibiotic resistance to tyrosine can be transferred, and thus can also lead to antibiotic resistance to other types of resistance to other antibiotics. So do you think we can develop antibiotics that can be used just for the animal industry and which may not affect the human, will not be transferred to humans? What do you think can be done about it? Because realistically, the poultry industry cannot avoid using antibiotics. Anyway, I saw I was evaluator of the ECWRG project, and good job, you came out with good results. Okay, go ahead.
So that is an excellent question from my very excellent microbiology professor when I was in undergraduate. And actually, I think for a start, it is a very good point. One of the things that we have to consider in terms of policy is just even the minimum standard of regulating the use of antibiotics, which are of medical importance. So there are antibiotics that can be specifically used for animals, but the current practice is actually it's easy to use antibiotics that are relevant for human health. And so if we can start with those types of policies and actually progress into a more stringent measure as we develop better systems while balancing this other aspect that are important for our productivity as well as for food production. So it's certainly a lot of thought, and I think it takes a community to actually solve this problem, ma'am. But yeah, that is a very good insight. Thank you for that.
Thank you, Joyce.
All right. So Are there other questions from the audience? I don't see any more raised hands.
Can I ask another question then, if nobody will
Yes,
ask?
of course. Yes.
What is the mechanism now of MR transfer? Are there more updated ways, mechanisms by which genes resistance can be transferred, maybe across borders?
Actually, we publish a review, and I would like to refer to that. The first author is Ivan Imperial, and then it's myself. It's published in Frontiers in Microbiology in 2016, and we've actually elaborated this answers to this question, ma'am. So I would. But certainly there's different levels. Like if it's a plasmid encoded, then the transfer would be more the higher risk. It's chromosomally encoded. But for the details, ma'am, I would suggest the audience to actually refer to this very comprehensive review that we publish.
Okay, thank you.
Right. So, Joyce, I think it's been a full and very, very well, exciting, stimulating hour with you, sharing all your projects with us over the last 10 years. And well, I know that your students are inspired by you, and they have their own missions in the SUCs or other universities where they are now leaders in their respective areas of research. So talking about being a true academic mentor, I think you're doing a great job. And perhaps the final question in my mind is about the data arts, the Real Data Arts initiative of yours. And you showed some of your photos and described your experience with non-scientist viewers and visitors. And, it's still, bothers me how the general scientific literacy in our country is low. So I'm just curious how, the non-scientists or the laymen reacted to the beautiful micrographs that you showed, say from the confocal microscope. It's one thing to appreciate the beauty or the art of it, the dyes and the patterns. It's another to really do a deep dive into the science, to be able to understand of all things, cellular and molecular science, which is really a big gap as far as laymen are concerned. So I don't know how you're going to address that. I mean, it's one thing to see the art of it, another to really understand the science of it.
Yeah. So actually, that I think the beauty of that is that, different. That's why I always advocate for diversity. People have different realities, and we actually respect and not in a very non-judgmental way of how people actually perceive science, and whether our expectation for people to deep dive into things that we are thinking of is actually something that we should worry about. But what I actually experienced is that the beauty of communicating to different types of audience and actually pivot your communication on what actually interests them. And just to be able to explain cell biology in a quick manner, in a natural, in a normal conversation, and appreciate actually some of them, the reaction is that students are inspired about cell biology and molecular mechanism. And then you talk to an artist, and they actually they speak their interest in science. And then you talk about somebody that chlamydia actually matters to them, and they're actually actually very interested in learning what the actual impact of this, and actually that they do not know. And my hypothesis is, when you come home with a merchandise that will actually trigger your imagination of something that is relevant to you, that is a self-sustaining educational system, because once you start a question in your mind and you are curious about it and it matters to you, the information is available now in our smartphones. So this is a platform where it is a self-sustaining. I don't have to ask funding for it, and the kids would actually learn entrepreneurial skills and do market validation. And and then you have other scientists who's become interested in actually, some of us are passionate about something that is we're working on for many years. And when I talked to the geologist, actually this is a fun conversation. She showed me some beautiful photos of rocks, and something I can relate to. And so there are many scientists actually, and we're thinking of coming up with a cooperative where we actually engage the public with our whatever we want to communicate. And this is the thing is, this is easy to produce. I have a collaborator already from the industry. When we actually was given opportunity to launch this, we only have 2 weeks, and my industry partner actually delivered the products in a few days. So when you collaborate with industry, they're very quick. But it's actually a really promising venture. It's a fun way, and also so it's something that I think worth trying, because this is a self-sustaining educational and a communication platform that we can actually introduce. If we have in the market designs of like other things like flowers or philosophy or religion or whatever, can we actually advocate science by having this advertised in a common merchandise that people will actually be? When you have a visual cue, you start thinking about it. So that's the idea.
It's science as part of culture. It's a cultural thing, right? Yeah. So part of our culture. So thank you so much, Joyce. I really hope to get to know more of your projects. I don't know if I told you that I was recently asked to join the technical working group for the Eco Park and Innovation Hub of the UP system by President Gigil. So I'll really look a lot more into your strategy for moving forward innovation in our in the university. Well, I still have to think of how to bridge that gap between innovation and commercialization in UP, because it's really tough, right? There's a resistance to it. Anyways, thank you everyone for joining us today. I think it's been another a wonderful, insightful exchange of ideas. And I'd like to thank again Joyce for your 10 years of accomplishments. And at this point, I would just like to say that we're all part of this innovation ecosystem, and we're trying to showcase our innovators within the academic and startup communities. And I was just telling Dr. Alsa Rafika that together, the two of us would have to probably invite innovators from the bigger or the larger industries. Okay. And then we would have to, lobby government to support more of the innovations that are already existing in our country. So next Friday, we will have a talk that is related again to AI, so artificial intelligence in health research, in healthcare. This will be presented by MD Dr. Professor Michael T. of the UP College of Medicine and PGH, who was recently appointed the new Chancellor of UP Manila. And he gave me the commitment to speak in this series before he became Chancellor. So I'd like to thank Mike in advance. I hope you can join us next Friday. And then for the last Friday of November, we have Dr. Joey Ocon of UP Diliman Engineering, who is a leader in batteries research and innovation. All right, so maybe just briefly again, reminding everybody, if you have the time to write a position paper related to innovation, the barriers to innovation and solutions, please do so. And if you have any grants that you might want to aim for, there will be innovation grants next year, but still in the process of being finalized in terms of the criteria and the grant process. But I think this innovation series, we're now like maybe we've featured about 12 to 15 innovators. I think that we would keep this list of innovators in mind, and perhaps we could solicit proposals from them or alert them about these proposals when the call is made early next year. Okay, so with that, I'd like to thank everyone again. In particular, we would like to thank Feb Esclaras for making sure that this runs smoothly. And thank you all once again for your continuing patronage of this Fireside Side series. I'd like to thank Alvin, who is always so busy, always traveling. He's again in Taiwan, where he's been recognized for his accomplishments. And most of all, thank you, Joyce. You're looking very lovely and very, very enthusiastic about your work, inspired by your students. Thank you.
Thank you. And thank you for my students, and thank you all for your time and attention.
Yeah. All right. So with that, I think we can end this event. And thank you once again. Till next Friday. Just let everyone know that these events are recorded and they can be found, they can be watched, from our PAASE website. Thank you.